From the early days of bulky, hand-wired electronics to the sleek, ultra-thin flexible boards we see today, circuit board technology has been the silent, unsung hero of our digital revolution. It's the very backbone that supports everything from your smartphone to the satellites orbiting our planet. In this video, we're going to dive deep into the fascinating evolution of circuit boards. We'll explore the key technological milestones that brought us here and look ahead to the mind-bending innovations that will power the next generation of electronics. So, get ready to journey through the intricate world of PCBs, where every tiny trace tells a story of human ingenuity. Our journey begins way back in the 1940s. Before the printed circuit board, or PCB, creating an electronic device was a painstaking process of connecting individual components with a messy web of wires. It was complex, unreliable, and incredibly difficult to mass-produce. Then came a revolutionary idea: why not print the connections directly onto a board? The first PCBs used copper tracks etched onto a base of phenolic paper. This simple-sounding breakthrough was a game-changer. It made electronics more compact, more durable, and far easier to assemble. This innovation wasn't just a convenience, it was the spark that ignited the consumer electronics boom. By the 1960s, these early circuit boards were powering the radios in our living rooms, the televisions that brought the world into our homes, and the first generation of room-sized computers. This humble beginning laid the essential foundation for the entire world of modern electronics we know today. As the ambition of engineers grew, so did the complexity of our devices. A single-layer board just wasn't enough to handle the intricate demands of emerging technologies. The solution: go vertical. In the 1980s and 90s, engineers began stacking multiple layers of copper and insulation, creating what we call multi-layer PCBs. Imagine a multi-story building for electrical signals. This innovation allowed for vastly more complex and dense designs in a much smaller footprint. It was the perfect technology for the rise of microprocessors and the personal computer revolution. Suddenly, the power of a mainframe could be shrunk to fit on a desk. Multi-layer technology gave us faster signal transmission by shortening the paths signals had to travel, provided better shielding against electronic interference, and dramatically increased overall reliability. This wasn't just an incremental improvement, it was the key that unlocked the tech boom of the modern age, shaping the computers, phones, and gadgets that would soon define our lives. The next great leap forward was driven by an insatiable demand for smaller, more powerful devices. This led to the era of miniaturization and the widespread adoption of surface mount technology, or SMT. Before SMT, components had legs that were inserted through holes in the board and soldered on the other side. SMT changed everything by allowing components to be soldered directly onto the surface of the board. This seemingly small change had massive implications. Components could be made smaller, packed closer together, and placed on both sides of the board, drastically reducing the overall size while boosting performance. This is the technology that made sleek smartphones, then laptops, and today's wearable devices possible. At the same time, the manufacturing process itself was undergoing a revolution. Precision robotics began to dominate PCB assembly lines. High-speed pick-and-place machines could position thousands of components per hour with microscopic accuracy, and automated soldering ensured every connection was perfect. This fusion of SMT and automation didn't just make our gadgets smaller, it made them more powerful, more reliable, and more accessible than ever before. As we moved into the 2010s, the rigid, flat circuit board began to bend, fold, and adapt to our needs. This new wave of innovation brought us flexible and rigid flex PCBs. Made from materials like polyamide, these boards can be twisted and folded to fit into the most complex and tightest of spaces without breaking. This technology is absolutely critical in devices where space and shape are paramount. Think of the intricate electronics inside a digital camera lens, the foldable screen of a modern smartphone, or the life-saving circuits woven into a medical implant. These boards are also essential in aerospace, where every gram of weight and every millimeter of space counts. But the innovation didn't stop there. engineers started experimenting with incredible new materials. Graphene, with its amazing conductivity and strength, conductive inks that allow us to literally print circuits onto various surfaces. And advanced polymers open the door to concepts once considered science fiction, like wearable circuits embedded directly into clothing and even 3D printed electronics that can be created on demand. So, where do we go from here? The future of circuit board technology looks smarter, faster, and more sustainable than ever. We're on the cusp of some truly transformative breakthroughs. First, imagine circuit boards with embedded AI. These self-monitoring boards will be able to diagnose their own faults in real time and even predict failures before they happen, leading to ultra-reliable systems. Next, we're looking at optical interconnects. Instead of sending electrical signals through copper traces, future boards will use light to communicate. This means data transmission at speeds we can barely comprehend today, completely eliminating electronic bottlenecks. We'll also see the rise of nanomaterial PCBs. These boards, built from materials engineered at the atomic level, will be ultra-thin, incredibly heat-resistant, and potentially even transparent. And as we become more environmentally conscious, biodegradable PCBs made from sustainable, eco-friendly materials will help tackle the growing problem of electronic waste. Finally, we are entering the quantum era. Specialized, cryogenically cooled circuit boards are being developed right now to control the delicate quantum bits, or qubits, that will power the next generation of quantum computers. Tomorrow's boards won't just be passive platforms, they will think, flex, and communicate with light. From those first simple copper tracks on paper to the intelligent, high-powered nanoboards of the future. The circuit board has been a constant symbol of human ingenuity and our relentless drive to innovate. It's an evolution that has mirrored our own technological progress, enabling every major leap forward in the digital age. As we move into an exciting new era defined by quantum computing, fully flexible devices, and deep AI integration. One thing is absolutely certain: the potential for circuit board technology is truly limitless. And it will continue to be the foundation upon which we engineer tomorrow, one layer at a time. Thanks so much for watching. If you found this journey through technology fascinating, don't forget to hit that like button and subscribe for more deep dives into the tech that shapes our world. We'll see you in the next one.